In this video, we will be studying geometric sequence and series, and we will learn how to apply these formulas about geometric sequence or geometric series. These formulas are given in the IB Math booklet. So first, we will understand the difference between a geometric sequence and an arithmetic sequence. As we did in a previous video, we said that in arithmetic sequences, the numbers increase or decrease by the same amount each time. So here we have an example of an arithmetic sequence. And as we see here, all the numbers increase by the same amount, which is here 4. So as we see, 5 plus 4 would be 9, and 9 plus 4 would be 13, 13 plus 4 would be 17, and so on. So this is an arithmetic sequence, and this 4 is called the common difference D. So arithmetic sequences increase or decrease by the same number. So we add or subtract a certain number, which is the common difference. So what is then geometric sequence? We will have now some examples. In geometric sequence, numbers increase or decrease by multiplication rather than addition or subtraction as in arithmetic sequence. Here we will have an example. 3, 6, 12, 24, 48, and so on. As we see here, the numbers don't increase by the same amount, so this is not an arithmetic sequence. Instead, here, numbers get multiplied by 2 each time, which makes it a geometric sequence. So here, in geometric sequences, we multiply any term by a certain number, like here 2, to get the subsequent or the next term. This 2 here is called the common ratio R. So the common ratio R is 2 in our example. Another example about a geometric sequence would be like this. For example, we have 40, then 20, 10, 5, 2.5, and so on. As we notice here, each term is half of the previous term. So that's why here the common ratio R would be half. If we multiply 40 by half, we would get 20, and 20 times half would be 10, and so on. So the common ratio R here is half. And now we will have a very important idea about the common ratio R in geometric sequences. R, or the common ratio, would be any term or any number divided by the previous term. So for example, to get the common ratio R, we can divide the second term by the first term, or we can also equivalently divide the third term by the second term, or the fourth one by the one before it, or the third, and so on. So here, notice that if we divide 48 by 24, we would get 2, and it will be the same if we divide 12 by 6. Here, if we divide 5 by 10 or 10 by 20, we would get the common ratio half. Another important example about geometric sequence would be this. Let's start with 3, then negative 6, then we have positive 12, negative 24, 48, and so on. Here, as we see, we also have a geometric sequence, but here it alternates between positive, negative, and so on. Because here the common ratio R is a negative number, which is here negative 2. Check now, if we multiply 3 by negative 2, we have negative 6, and so on. Or if you divide any term, like 12, by the previous term, negative 6, you will have negative 2. Now we will focus on this geometric sequence. Here, as we said before, the common ratio R is equal to 2. We will solve some common questions on geometric sequences that we might counter in exam. So the first question would be like this here. We need to find the nth term or the general term of geometric sequence, which is given by this formula here. So in this example, if we need to find the nth term, un, it would be Here we have the first term u1, which is in our example 3. So we have 3 multiplied by, we have r to the power of n minus 1. In our example r would be 2. So we have 2 to the power of n minus 1. So this is the nth term. N is the order or the position of the term. So for example, when n equals 10, you will get the 10th term. Let's find it now in our example. So if we need to find the 10th term, we replace every n here by 10. So we will have 3 multiplied by 2 to the power of n minus 1, which is here 10 minus 1, or 9. And this will be 1536. Which means if we continue writing some more numbers here up to the 10th number, then the 10th number or the 10th term would be 1536. Now, another question that we might encounter in sequences is that finding the sum of n terms, which is given by this formula. You can use this formula here or equivalently this. Both will give you the same answer. So here, what is the sum of n terms? Let's now take these numbers here again. This is here, as we said, a geometric sequence. Once we add all the numbers or all the terms up like this, then it becomes a geometric series instead of sequence. So a series is the sum of the terms of a sequence. So here, let's find S10, which means the sum of the first 10 terms of this sequence. Here, n will be 10. We are adding the first 10 numbers or the first 10 terms of this geometric sequence. In this formula here, as you see, we have u1 or the first term, which is here 3, then multiplied by r to the power of n minus 1. So here the common ratio, as we said, 2. So 2 to the power of n, which is here 10 minus 1, divided by r minus 1. Of course, you can use this formula or this, no difference between them. Now here, if we evaluate this in the calculator, we would get 3069, which means if we add up the first 10 terms here in this geometric series, the first 10 terms up to the 10th that we have here as we found, we would get 3069. Let's now move on again to this geometric sequence that we studied before, and we found that the common ratio is half. Here, a common question that we might be asked is that we need to find the sum to infinity, which means we need to find the sum of all of these infinite terms, not only like just 10 terms or 20 terms as we did in the previous example, where we added up a finite number of terms or only 10 terms. Here, we need to add up all of these infinite numbers. And for that, we will use this formula here, the sum to infinity, or the sum of all of the infinite numbers. This concept, the sum to infinity, is in all IB Math courses, except for the IB Math AISL. So if you study IB Math AISL, you don't need to study this concept. So here, to find the sum to infinity, we will apply this formula. We have here u1, or the first term here, which is 40, divided by 1 minus r, which is in our example half. So here we have 1 minus half. And here, 1 minus half will be half. 40 divided by half is the same as 40 multiplied by 2, which is 80. So the sum of all of these infinite numbers or terms will be just a limited number, 80, not like a very large number or infinity. So here we need to clarify some ideas about this concept. First, this formula is valid to use only if the common ratio r, or the absolute value of r, is less than 1, which means equivalently r must be between 1 and negative 1 only. So if r is not within this range, then we cannot use this formula or the sum to infinity, and in that case we will not be asked about this concept. So here yr must be between negative 1 and 1. As you see here in this sequence, if you continue writing more and more numbers after 2.5, the numbers here will get very, very small, so that their sum or their addition will be insignificant. And for these numbers to get very, very small eventually, the common ratio r must be between negative 1 and 1. If the common ratio r is greater than 1, for example, then these numbers will get bigger and bigger, and their sum will be just a very large number or infinity.